Hello, I'm Tyler Grunendijk with Product Training, and I'm joined by Clint Recker, our drill product manager. We have recently launched our 4th generation of drills. As part of this launch, we've also incorporated Automated Rod Exchange, or ARE for short. This feature really derives from our desire to create a drill with features that match today's market needs. Clint, you've been there from the beginning, having conversations with customers, talking with our dealers, gathering all that feedback, and bringing it back to our engineering teams here. So Clint, can you share with us a little bit about how this all began?
ARE comes from feedback from our customers, and it's really around the challenge of finding operators. This system is intended to be able to lessen the training time that it takes for new operators, as well as to lessen the workload of skilled operators. In addition to making a system that was able to train and help new operators, we also wanted to make a smart system, one that helps protect the components.
Speaking of components and technology, as we transition from our Series 3 to our Gen 4 platform, what are some key elements of the drill that have had to change, or maybe technology that's had to be incorporated, allowing features such as ARE to be present on the drill?
All of the work is happening with our control system. That's really where we spent a lot of intensive time developing, years of development, and we use sensors that we already are using on our machines today. Things like proximity sensors, pressure transducers, and gearbox float sensors. Those are really what's working in the background to make this process happen, but also is what helps to protect the components, items like subsavers, drill rod, and how we really want to extend the life and maximize the life of those wear components.
Yeah, it sounds like a lot of intentionality around using components that we're familiar with, that are proven. What about testing? The system itself, that hasn't been around. ARE, automation, what did that testing process look like, and how did we go to market with confidence?
We've done a lot of testing with our internal corporate test team. They've put tens of thousands of cycles on this machine to ensure that it's reliable. And then the next step was actually to get it out into the field. And so we've worked with several customers to get it onto their job sites, for them to be able to use ARE and give us feedback. And ultimately, that's what's led to the current production machine going out the door.
Thanks for that, Clint. That's some great insight. Now, let's transition and take a look at how ARE actually functions. The operator will begin by drilling a rod out. This will be the same manual process as it would be on an S3 drill. The left joystick will control rotation, and the right joystick will control thrust. After a rod has been drilled out, the operator will stop thrust and rotation by placing the joysticks in neutral and close the front vise. This will clamp down on the downhole rod and hold it in place. At this point in the drilling process, ARE can be activated. Notice that the operator is not touching any buttons or moving the joysticks. Watch as ARE fully automates the rod exchange. While pulling back rod, start by manually retracting the rod the same way as a Series 3 drill. When the carriage has reached its stop point at the rear of the rack, a chirp will sound. After clamping the front vise, the operator can then choose to activate ARE. This process is the same as activating ARE during drill out. Starting the fully automated process of unthreading the rod and placing it back in the rod box. Notice that during ARE, multiple functions are being completed at the same time, just like an experienced operator would. If an operator gets out of the seat, touches a joystick, or the sensors see something wrong, like a bent rod, ARE will stop. There is no resume button because when a fault occurs, ARE is designed to prioritize the integrity of the machine over the convenience of automation. It has sensed a problem with the system, and it wants the operator to investigate. Once the issue is resolved, the operator completes the cycle manually and can resume using ARE on the next rod exchange sequence. So in the above example, you'll note, operator knowledge of a manual rod exchange is still required when addressing a fault. So how does ARE still offer meaningful assistance? Well, say you have an operator who's still learning. They're going to see visual cues on the joystick and screen throughout the automated rod exchange, providing them with an opportunity to familiarize themselves with the operational sequence. Here's how a few of those cues work. Being able to watch the step-by-step descriptions and live animations on the screen helps them understand the operational sequence. During ARE, Flashing joystick buttons will indicate which function is currently being automated. Combining these two sources of information results in an active learning experience, allowing a new operator to watch and learn before being required to manually cycle rod on their own. For more information about ARE and the D24 Gen 4 platform, please reach out to your Vermeer product specialist.